The desert at night is a place of stillness. When the sun sets and the heat of the day begins to fade, the land cools slowly. The air becomes crisp and clear, and the sky above transforms into something vast and endless. There are no city lights here, no glowing signs or street lamps to soften the darkness. The desert night is pure and uninterrupted, allowing the stars to appear with a clarity that feels almost impossible in other places. The darkness in the desert is different from darkness in other environments. It is complete and absolute, stretching in every direction without obstruction. There are no trees to block the view, no hills that rise too high, no buildings that interrupt the horizon. The landscape is open and flat, or gently rolling, and the sky seems to extend forever. When you look up, you are looking at the universe without anything standing in the way. Stars become visible as the last light of day disappears. At first, only the brightest ones appear, small points of light scattered across the deepening blue. As the sky darkens further, more stars emerge, and then more still, until the entire sky is filled with them. They are not evenly distributed but clustered in some areas and sparse in others, creating patterns that have been observed for thousands of years. The Milky Way becomes visible in the desert night, a wide band of light that stretches across the sky. It looks like a soft, glowing river, faint but unmistakable. This band is made up of countless stars, so many that they blend together into a gentle luminescence. The Milky Way is the galaxy we live in, and when we look at it from Earth, we are looking toward the center of that galaxy, seeing the combined light of billions of distant suns. The air in the desert is dry, which helps the stars appear more clearly. Water vapor in the atmosphere can scatter light and make the sky appear hazy, but in the desert there is very little moisture. The air is thin and clean, allowing the light from the stars to travel through it without being scattered or diffused. This is why desert skies are some of the clearest on Earth, and why observatories are often built in desert regions. The temperature drops quickly after sunset. During the day, the desert sand and rocks absorb heat from the sun, storing it in their surfaces. But once the sun is gone, that heat radiates back into the atmosphere, and without cloud cover to trap it, the warmth escapes into space. The temperature can drop by many degrees in just a few hours, and by the middle of the night, the air can feel quite cold. This coolness is gentle and refreshing after the heat of the day, and it adds to the stillness of the desert night. The silence in the desert is profound. There are no sounds of traffic, no hum of machinery, no voices carrying on the wind. Occasionally, a soft breeze moves across the sand, creating a faint whisper as it passes. Sometimes, a nocturnal animal moves quietly through the darkness, its footsteps barely audible. But for the most part, the desert at night is quiet, a kind of silence that feels rare and complete. Ancient travelers moved through deserts at night, using the stars to guide them. Without modern tools or maps, they relied on the patterns in the sky to navigate across the vast, featureless landscape. The stars provided direction, marking the north and south, the east and west. These travelers learned which stars rose at certain times of year, which constellations moved across the sky as the night progressed, and how to use these markers to find their way. The North Star, also called Polaris, has been used for navigation for centuries. It sits almost directly above the North Pole, which means it appears to stay in the same place in the sky while all the other stars rotate around it. In the northern hemisphere, finding Polaris means finding north, a fixed point in the otherwise moving sky. Desert travelers would locate this star and use it to orient themselves, knowing that as long as they could see it, they could find their direction. Constellations are patterns of stars that have been recognized and named by cultures around the world. These patterns do not represent actual groupings of stars. The stars in a constellation are often very far apart from one another and have no physical connection. But from our perspective on Earth, they appear to form shapes, and these shapes have been used to tell stories, mark seasons, and navigate. Orion is one of the most recognizable constellations, visible from both the northern and southern hemispheres. It is often described as a hunter, with 3 bright stars forming a belt across the middle. 2 brighter stars mark the shoulders, and 2 more mark the feet. Orion is easy to find in the winter sky, and it has been recognized by many cultures throughout history. In the desert, Orion rises in the east and moves slowly across the southern sky, a familiar pattern in the vast darkness. The stars in Orion are not all the same distance from Earth. Betelgeuse, the bright reddish star that marks one of Orion's shoulders, is hundreds of light-years away. Rigel, the bright blue star at the opposite corner, is even farther. The 3 stars of Orion's belt are each at different distances as well. But from Earth, they all appear to be part of the same pattern, arranged in a way that our eyes and minds recognize as a shape. Cassiopeia is another constellation visible in the northern sky. It looks like a slightly crooked letter W or M, depending on the time of year and where it sits in the sky. Cassiopeia is made up of 5 bright stars that form a simple, elegant shape. It rotates around the North Star throughout the night, sometimes appearing upright and sometimes upside down. In the desert, where the sky is dark and clear, Cassiopeia is easy to spot, a gentle marker in the heavens. The Big Dipper is not a constellation itself, but rather an asterism, a recognizable pattern within a larger constellation. It is part of Ursa Major, the Great Bear, and it consists of 7 bright stars that form the shape of a ladle or dipper. The 2 stars at the end of the dipper's bowl point toward Polaris, making the Big Dipper a helpful tool for finding the North Star. The Big Dipper is visible throughout the year in many northern locations, circling around Polaris as the Earth rotates. Scorpius is a constellation best seen from southern deserts or lower latitudes. It has a distinctive curved shape that resembles a scorpion, with a long tail that arcs across the sky. The bright star Antares marks the heart of the scorpion, a reddish point of light that stands out against the surrounding stars. Scorpius is visible during the summer months, rising in the southeast and moving across the southern sky. In the clear desert night, its shape is vivid and easy to trace. Taurus is a constellation that appears in the winter sky, featuring a V-shaped cluster of stars that represents the face of a bull. The bright star Aldebaran marks the bull's eye, glowing with a warm, orange hue. Nearby is the Pleiades, a small cluster of stars that looks like a tiny dipper or a group of faint jewels. The Pleiades are actually hundreds of stars, but from Earth, only the brightest 6 or 7 are visible to the naked eye. In the desert, where the sky is dark, the Pleiades shimmer gently, a delicate cluster in the vastness of space. Leo is a constellation that rises in the spring, shaped like a crouching lion. Its brightest star, Regulus, marks the lion's heart, a blue-white point of light near the front of the constellation. Above Regulus is a curved line of stars that forms a backward question mark, representing the lion's head and menere. Leo is prominent in the spring sky, and in the desert, it rises in the east and moves across the southern part of the sky as the night progresses. The stars we see from the desert are the same stars that have been observed for thousands of years. Ancient cultures looked up at the same sky and saw the same patterns, though they interpreted them differently. Some cultures saw animals, others saw gods or heroes, and still others saw tools or objects from their daily lives. The stories varied, but the act of looking up and finding meaning in the stars was universal. The Sumerians, who lived in ancient Mesopotamia, were among the first to record observations of the night sky. They divided the sky into regions and created early star catalogues, documenting which stars appeared at which times of year. Their observations were practical, used to track the seasons and determine the best times for planting and harvesting. But they also saw the sky as a place of divine significance, a realm where the gods resided and influenced the world below. The ancient Egyptians observed the stars from the deserts along the Nile. They paid particular attention to Sirius, the brightest star in the night sky, which appeared just before sunrise in late summer. This event, known as the heliacal rising of Sirius, coincided with the annual flooding of the Nile, a crucial event for Egyptian agriculture. The appearance of Sirius was seen as a herald of renewal and abundance, and it was incorporated into their calendar and religious practices. The Bedouin people, who have lived in the deserts of the Arabian Peninsula for centuries, developed a deep knowledge of the stars. As nomadic herders, they traveled great distances across the desert, often at night to avoid the heat of the day. The stars were their map, guiding them from one oasis to another. They knew which stars rose in which season, and they used this knowledge to navigate and to mark the passage of time. In the deserts of North America, indigenous peoples also observed the stars and incorporated them into their cultures. The Navajo people saw constellations that represented figures from their stories and traditions. The Chumash people of California created complex astronomical systems, tracking the positions of stars and planets and using this knowledge in their ceremonies. The sky was not separate from the land but deeply connected to it, a source of guidance and meaning. The ancient Greeks developed many of the constellation names and stories that are still used today. They saw the sky as a canvas for their mythology, placing heroes, monsters, and gods among the stars. Orion, Cassiopeia, Andromeda, Perseus. These names come from Greek myths, stories of adventure and transformation. The Greeks also made early attempts to understand the nature of the stars themselves, proposing that they might be distant suns or other celestial objects. Hipparchus, a Greek astronomer who lived over 2,000 years ago, created one of the first comprehensive star catalogues. He measured the positions and brightness of over 1,000 stars, recording them with remarkable precision. His work laid the foundation for later astronomers and demonstrated that the stars, while appearing fixed, actually move slowly over very long periods of time. This movement, called precession, causes the position of the stars to shift gradually over centuries. The sky at night is not static. As the Earth rotates, the stars appear to move across the sky from east to west. This movement is slow and steady, taking about 12 hours for a star to travel from the eastern horizon to the western horizon. If you watch a single star for an hour or two, you can see it shift its position, though the change is gradual and gentle. Different constellations are visible at different times of year because the Earth orbits the Sun. As we move around the Sun, our nighttime view points toward different parts of the galaxy. In the summer, we see constellations that are on one side of the sky, and in the winter, we see constellations that are on the opposite side. This creates a seasonal rhythm to the stars, with certain patterns appearing and disappearing as the year progresses. Planets are also visible from the desert, though they look different from stars. They do not twinkle in the same way because they are closer to Earth and their light is steadier. Venus is often the brightest object in the night sky after the Moon, appearing in the west after sunset or in the east before sunrise. Mars has a reddish hue, while Jupiter is bright and white. Saturn is fainter but still visible to the naked eye, and with patience, you can watch these planets move slowly against the background of stars over the course of weeks and months. The Moon, when it is visible, dominates the desert sky. It rises in the east and sets in the west, just like the stars, but its brightness can wash out the fainter stars, making them harder to see. When the Moon is full, the desert landscape is bathed in soft, silvery light, and shadows appear on the sand. But when the Moon is new and the sky is completely dark, the stars emerge in their full glory, and the Milky Way becomes a prominent feature overhead. Meteor showers occur several times a year, when the Earth passes through the debris left behind by comets. These tiny particles burn up in the atmosphere, creating brief streaks of light across the sky. In the desert, where the sky is dark and unobstructed, meteor showers are particularly easy to see. The meteors appear suddenly, flashing across the sky for a second or two before disappearing. They are silent and quick, small reminders of the constant movement and activity in space. The Perseids are a meteor shower that occurs in August, when the Earth passes through the debris trail of a comet called Swift-Tuttle. On a clear desert night during the peak of the Perseids, you might see dozens of meteors in an hour, each one a brief spark in the darkness. The meteors appear to radiate from the constellation Perseus, which is how the shower got its name, though they can appear anywhere in the sky. The light from the stars takes time to reach us. The Sun is about 8 light minutes away, meaning the light we see from it left the Sun's surface 8 minutes ago. The next closest star, Proxima Centauri, is over 4 light-years away, meaning its light has been traveling through space for over 4 years before it reaches our eyes. Some of the stars we see in the desert sky are hundreds or even thousands of light-years away, and the light we observe tonight left those stars centuries ago. This means that when we look at the stars, we are looking back in time. The farther away a star is, the older the light we are seeing. In a sense, the night sky is a window into the past, showing us the universe as it was, not as it is now. This perspective is both humbling and calming, a reminder of the vastness of space and the slowness of time on a cosmic scale. The stars themselves are suns, massive spheres of hydrogen and helium undergoing nuclear fusion. This process releases enormous amounts of energy in the form of light and heat, which radiates outward into space. The Sun is an average star, neither particularly large nor particularly small, and it provides the energy that sustains life on Earth. The other stars in the sky are similar, each one a distant sun, some larger and brighter, some smaller and dimmer. Stars are born in clouds of gas and dust called nebulae. These clouds are vast and cold, drifting through space for millions of years. Gradually, gravity pulls the gas and dust together, creating denser regions within the cloud. As these regions grow more massive, the pressure and temperature at their centers increase, until eventually nuclear fusion begins. At that moment, a star is born, and it begins to shine. Stars live for millions or billions of years, depending on their size. Larger stars burn through their fuel quickly and have shorter lifespans, while smaller stars burn more slowly and can last for trillions of years. Our Sun is about halfway through its life, having formed roughly 4.6 billion years ago. It will continue to shine for another 5 billion years before it exhausts its hydrogen fuel and begins to change. When a star runs out of fuel, it undergoes a transformation. Smaller stars, like the Sun, expand into red giants, their outer layers puffing outward while the core contracts. Eventually, the outer layers drift away into space, leaving behind a small, dense core called a white dwarf. Larger stars end their lives more dramatically, exploding in supernovae that release tremendous amounts of energy and create new elements that are scattered into space. The elements that make up the Earth and everything on it were created inside stars. Hydrogen and helium formed in the early universe, but heavier elements like carbon, oxygen, iron, and gold were forged in the cores of stars and released into space when those stars died. These elements drifted through space for millions of years before they came together to form new stars, planets, and eventually life. In this way, we are connected to the stars, made of the same materials that were created in their cores. The desert night offers a perspective that is difficult to find in other places. The darkness, the silence, and the clarity of the sky create an environment where the universe feels close and accessible. There is no urgency here, no demand for action or attention. The stars simply are, existing in their slow, ancient rhythms, indifferent to the concerns of the world below. Looking up at the stars from the desert, it is easy to feel small. The distances involved are so vast that they are difficult to comprehend. The light we see has traveled across unimaginable stretches of space, crossing voids where there is nothing but emptiness. And yet, despite this vastness, there is something comforting about the night sky. It is constant and reliable, a presence that has been there for as long as humans have looked up. Ancient philosophers gazed at the stars and wondered about the nature of the universe. Aristotle believed that the stars were fixed on a celestial sphere that rotated around the Earth. Ptolemy created a detailed model of the heavens, describing the movements of the planets and stars in mathematical terms. These early thinkers did not have telescopes or modern instruments, but they observed carefully and thought deeply, laying the groundwork for the astronomy that would come later. Nicolaus Copernicus, in the 16th century, proposed that the Earth was not the center of the universe but rather orbited the Sun along with the other planets. This idea was revolutionary, challenging centuries of accepted belief. Galileo Galilei, a few decades later, used a telescope to observe the moons of Jupiter, the phases of Venus, and the mountains on the Moon, providing evidence that supported Copernicus's model. These discoveries changed the way humanity understood its place in the cosmos. Johannes Kepler refined the understanding of planetary motion, showing that planets move in elliptical orbits rather than perfect circles. Isaac Newton explained why they moved this way, developing the law of universal gravitation, which described how objects attract each other across space. These insights, built on careful observation and mathematical reasoning, revealed that the universe operates according to consistent, understandable principles. The development of larger and more powerful telescopes allowed astronomers to see farther into space. They discovered that the Milky Way was not the only galaxy but one of countless galaxies scattered throughout the universe. Edwin Hubble, in the 20th century, observed that these galaxies were moving away from each other, suggesting that the universe itself was expanding. This discovery led to the theory of the Big Bang, the idea that the universe began as a single point and has been expanding ever since. The universe is approximately 13.8 billion years old. In the first moments after the Big Bang, it was unimaginably hot and dense, filled with energy and fundamental particles. As it expanded, it cooled, and particles began to combine to form atoms. Over millions of years, these atoms came together under the influence of gravity, creating the first stars and galaxies. The universe has been evolving ever since, with stars forming, living, and dying, and galaxies drifting through space. The night sky we see from the desert is a snapshot of this ongoing process. Some of the stars we observe are young, only a few million years old. Others are ancient, having formed billions of years ago when the universe was much younger. The light from these stars has traveled across vast distances to reach us, carrying information about their temperature, composition, and motion. The stars do not exist in isolation. They are part of galaxies, massive collections of stars, gas, dust, and dark matter held together by gravity. The Milky Way contains hundreds of billions of stars, and it is just one galaxy among hundreds of billions in the observable universe. Each galaxy is a vast system, with its own structure and history, slowly rotating in space. Between the stars and galaxies is mostly empty space, a vacuum where there is almost nothing, just a few atoms per cubic meter, along with cosmic radiation and particles that drift through the void. This emptiness is profound, stretching for light years between stars and for millions of light years between galaxies. And yet, even in this emptiness, there is a kind of beauty, a vastness that is both intimidating and awe-inspiring. The desert night provides a direct connection to this cosmic perspective. Standing on the sand, looking up at the stars, you are looking out into space and back into time. The light entering your eyes left a distant star decades, centuries, or millennia ago, traveling through the void to reach you at this exact moment. That light is ancient, carrying information from a time before cities existed, before humans existed, from an era when the universe was younger and different. This perspective can be calming. The concerns of daily life, the challenges, the stresses, the uncertainties, seem smaller when placed against the backdrop of the cosmos. The universe operates on timescales that dwarf human lifespans, on scales that make individual worries feel temporary and manageable. The stars have been shining for billions of years, and they will continue to shine for billions more, indifferent to the passage of human events. The desert at night is a place where this perspective is easy to access. The darkness removes distractions, and the silence allows for quiet contemplation. There is no need to do anything, no need to solve problems or make decisions. You can simply be, existing in the moment, aware of the sky above and the ground below, connected to both the earth and the wider universe. The stillness of the desert night is almost meditative. The air is cool and calm, the temperature stable after the initial drop following sunset. The sand has given up its stored heat, and the rocks have cooled as well. The landscape is dark, visible only as faint shapes against the slightly lighter sky. There are no lights, no movement, nothing to pull your attention away from the stars. Time seems to slow in the desert at night. Without the usual markers of time, clocks, schedules, the movement of traffic or people, there is only the slow rotation of the sky. The stars move gradually across the heavens, the earth turning beneath them at a steady pace. An hour passes, then another, and the sky has shifted, the constellations in slightly different positions, but the overall sense of stillness remains. The ancient travelers who crossed the desert at night must have experienced this same stillness. They moved slowly, conserving their energy, guided by the stars. They rested during the heat of the day and traveled during the coolness of night, when the temperatures were more bearable and the stars could guide them. They knew the rhythms of the desert, the way the temperature changed, the way the wind moved, the way the stars rose and set. These travelers carried knowledge passed down through generations. They knew which stars appeared at which times of year, which constellations marked the changing seasons, which patterns indicated directions. This knowledge was practical and essential for survival, but it was also part of their culture, woven into their stories, their songs, their understanding of the world. The stars were not just tools for navigation but also sources of wonder and meaning. They were markers of time, indicators of the seasons, guides through the darkness. They were also reminders of the vastness of the world, of the forces beyond human control, of the mysteries that existed in the sky above. Looking at the stars from the desert, it is easy to understand why ancient cultures found them so significant. The stars are beautiful, distant, and eternal. They appear night after night, unchanging and reliable. They form patterns that the mind naturally seeks out, shapes that can be recognized and remembered. And they are mysterious, points of light whose true nature was unknown for most of human history. The invention of the telescope revealed that the stars were not mysterious lights but distant suns, similar to our own sun but farther away. This realization transformed our understanding of the universe. The stars were no longer unique, magical objects but part of a larger pattern, evidence of a universe filled with countless suns, each potentially surrounded by planets, each part of the same cosmic fabric. The telescope also revealed details that were invisible to the naked eye. Nebulae, which appeared as faint smudges in the night sky, were shown to be vast clouds of gas and dust, regions where new stars were forming. Galaxies, once thought to be nebulae within the Milky Way, were revealed to be separate systems, each containing billions of stars, scattered throughout space. These discoveries expanded the known universe, pushing its boundaries farther and farther. Each new observation revealed more complexity, more structure, more phenomena to study and understand. The universe was not a simple, static place but a dynamic, evolving system, filled with processes that operated over immense timescales and distances. Despite these discoveries, The night sky from the desert looks much the same as it always has. The stars still appear as points of light, scattered across the darkness. The constellations still form their familiar patterns. The Milky Way still stretches overhead like a glowing river. The experience of standing in the desert and looking up at the stars is fundamentally unchanged, a connection to something ancient and enduring. The darkness of the desert night is pure. There are no artificial lights to interfere, no glow on the horizon from distant cities, no street lamps or headlights to wash out the stars. The darkness is complete, and in this darkness, the stars emerge in their full brightness. The fainter stars, invisible in light-polluted areas, become visible here, filling the spaces between the brighter ones, creating a dense tapestry of light. This darkness is increasingly rare. As human civilization has grown, artificial light has spread across the planet. Cities glow at night, their lights visible from space, creating a persistent brightness that obscures the stars. Even in rural areas, the glow from distant cities can brighten the sky, making it difficult to see the Milky Way or the fainter constellations. The desert remains one of the few places where true darkness still exists, where the night sky can be seen as it has been seen for thousands of years. The stars visible from the desert include not just single points of light but also binary systems, where two stars orbit each other, and multiple star systems, where several stars are bound together by gravity. Many of the stars in the night sky are actually pairs or groups, though they appear as single points of light because they are so far away. Over time, these systems orbit each other, their movements governed by the same gravitational forces that keep planets in orbit around the Sun. Some stars vary in brightness, pulsing gently over periods of days or weeks. These variable stars expand and contract, their surfaces moving in and out in a regular rhythm. The changes in brightness are subtle and slow, visible only to careful observers or sensitive instruments. Other stars flare suddenly, releasing bursts of energy that briefly increase their brightness before fading back to normal. The stars are not evenly distributed across the sky. Some regions are dense with stars, particularly the band of the Milky Way, where we are looking edge-on into the disk of our galaxy. Other regions are sparse, with fewer stars visible. These variations create texture in the night sky, areas of brightness and areas of darkness, patterns that the eye naturally follows. Between the stars, there are dark patches where dust blocks the light from more distant stars. These dark nebulae are visible as voids in the Milky Way, regions where the background glow is interrupted. They are not truly empty but filled with cold gas and dust, too dense to allow light to pass through. These regions are often where new stars are forming, the raw material slowly condensing under gravity to create the next generation of suns. The experience of watching the stars from the desert is unhurried. There is no need to rush, no schedule to keep. The stars will continue to move across the sky whether you watch them or not, their motion slow and inevitable. You can sit or stand or lie down on the sand, looking up at the vastness above, letting your eyes adjust to the darkness, allowing the patterns to emerge. As your eyes adjust, you begin to see more. The faintest stars become visible, and the Milky Way appears brighter, its structure more detailed. You can see variations in brightness along its length, darker lanes where dust obscures the light, brighter regions where star clusters shine. The sky is not uniform but textured, filled with subtle differences that reveal themselves slowly. The air is still, the temperature cool but not uncomfortable. There is no wind, no movement except the slow rotation of the sky. The silence is deep, broken only occasionally by the faint sound of sand shifting or a distant animal moving through the darkness. The quiet is restful, allowing the mind to settle, to let go of the constant stream of thoughts and concerns that fill the waking day. Time becomes less important in the desert night. Without clocks or external markers, there is only the present moment, the stars above, the cool air, the silence. The usual rush of life fades away, replaced by a sense of timelessness, a feeling that this moment could stretch on indefinitely, that there is no urgency, no need to be anywhere else or do anything else. The stars continue their slow journey across the sky. Orion moves from the east toward the south, its familiar shape rotating as the Earth turns. Cassiopeia circles around the North Star, its W-shape tilting and shifting position. The Big Dipper rotates slowly, always pointing toward Polaris, a constant marker in the changing sky. The moon, if it is present, casts shadows across the sand. The shadows are soft and diffuse, not sharp like shadows under the sun, but gentle gradations of light and dark. The moonlight is reflected sunlight, bounced off the moon's surface and back to Earth, much dimmer than direct sunlight but still bright enough to illuminate the desert landscape. The rocks and dunes glow faintly in the moonlight, creating a quiet, silvery world. When the moon is absent, the desert is lit only by starlight. This light is faint, barely enough to see by, but it is sufficient to make out the general shapes of the landscape, the curve of a dune, the outline of a distant hill, the flat expanse of the desert floor. The starlight is soft and diffuse, casting no shadows, creating a landscape that feels dreamlike and unreal. The stars themselves are ancient. The light we see tonight left those stars long ago, traveling through space at the speed of light, covering vast distances to reach our eyes. The star Sirius, the brightest in the night sky, is about 8.6 light-years away, meaning its light has been traveling for 8.6 years before we see it. Betelgeuse, in Orion, is over 600 light-years away, so the light we see tonight left that star around the year 1400. This connection across time is part of what makes stargazing so profound. We are not just looking at objects in space but witnessing events that occurred in the past. The universe is revealing itself to us moment by moment, light arriving from distant sources, carrying information about what those sources were like when the light began its journey. The stars will continue to shine long after we are gone. They burn for millions or billions of years, their lifespan so long that human history is just a brief flicker in comparison. The stars that ancient people saw are mostly the same stars we see today, and they will be the same stars that future generations see, though their positions will shift slowly over time due to the motion of the Earth and the stars themselves. The desert night is a place of peace. The darkness is not threatening but comforting, a blanket that covers the land and allows the stars to emerge. The silence is not empty but full, filled with the presence of the sky and the landscape, the cool air and the distant stars. There is a sense of connection here, a feeling of being part of something larger, of existing within a universe that is vast and beautiful and old. Looking up at the stars, there is no need to understand everything, No need to know the names of every constellation or the distance to every star. It is enough to simply look, to observe, to be present in this moment under the night sky. The stars do not require anything from us. They simply exist, shining their light across the void, indifferent and eternal. The desert night continues, the stars moving slowly across the sky, the air cool and still. The world feels quiet and distant, as if the usual concerns and distractions have faded away, leaving only the present moment. The stars shine above, the sand stretches out below, and in between, there is only stillness and silence, a peaceful pause in the constant movement of life. The universe is vast, and the night sky is a reminder of that vastness. But it is also a reminder that we are part of this universe, connected to it through the elements that make up our bodies, through the light that reaches our eyes, through the air we breathe and the ground we stand on. The stars are distant, but they are not separate. They are part of the same cosmic story that includes the earth and everything on it. The desert at night is a place where this story feels close and accessible. The darkness removes the barriers between us and the sky, allowing the stars to appear as they truly are, ancient, distant, beautiful. The silence allows for contemplation, for reflection, for a quiet awareness of the universe and our small place within it. The stars continue to shine, the earth continues to turn, and the night continues its slow progression toward dawn. But for now, there is only the darkness, the silence, and the stars above, a timeless scene that has played out for billions of years and will continue for billions more. The desert night is gentle and still, a place of rest and peace, where the universe reveals itself in the form of distant lights scattered across the darkness. The stars shine quietly, ancient and enduring, marking the passage of time on a scale that makes human concerns seem small and temporary. There is comfort in this perspective, a sense that despite the challenges and uncertainties of life, the universe continues, vast and beautiful, indifferent but somehow reassuring in its permanence. The cool air, the soft darkness, the silent landscape, the stars above, all of these create a moment of stillness, a pause in the rush of life, a chance to simply be, to exist without urgency or expectation, to rest beneath the ancient light of distant suns.